All right, everybody, welcome to our third concept in chapter 4. In concepts 1 and 2, we were talking about graphing linear equations. We graphed them when they were in standard form, and we graphed them when they were in slope-intercept form. So those are the two forms that we're going to focus on. Eventually, I might get around to showing you point-slope form, but we're not going to spend a lot of time on point-slope. A majority of our time is going to be spent on standard and slope-intercept form. So, obviously, since we spent a couple days graphing, now we're going to get into writing the equations, which is just as easy, if not easier, to be perfectly honest. So before we jump right into things here, let's review quickly. We have slope-intercept form. How does it go? Y equals mx plus b. And let's label the parts of this equation. So we've got y is our, dependent variable, basically all of your outputs. Leave y alone, it'll always stay a variable, equals mx plus b, m being your slope, and x stays a variable, that's your independent variable or your input values, and b, y-intercept. So as you could probably guess, if we know these two pieces of information, we can just plug them into the equation to, well, make an equation, okay? So as you can tell below, we are given those exact two pieces of information. So we just literally need to plug them in to this y equals something x plus something, all right? We just need to plug it into the equation and make an equation. Okay, so 25, we have a slope of 5/3 and a y-intercept of 2. So this is going to be y equals, I'll do it in red, slope 5/3 x, and then plus your b, which is 2. Okay, and that's literally all we're doing until we get to the back. There's a little bit more on the back. But let's just quickly go through these. I'm going to stop using colors now. Hopefully you can see what I did here, okay? 27, slope is 3. We can leave it 3, but it'll be 3 over 1, same thing. And y-intercept is -2 this time, so pay attention to that negative. So we have y equals m. What's your m? The slope, so 3x plus, well, we could put plus -2, but plus and negative is the same thing as minus. So -2. Okay, let's keep going. 29, slope, y equals 1/3 x minus 1. Okay, just plugging all the information in. 31, y equals, now we have a negative slope, -5/4. Ooh, y-intercept is 0. You could put plus 0, but anything plus 0, for example, if we had like 5 plus 0, it's still going to be 5. It's not even there. You don't even have to write it. So you could put plus 0, or you could just leave it as y equals -5/4 x. Okay? Either answer that you give to me, I will accept. 33. Ooh, slope is 0. What do you think? Think back to our video for part 2 of 4.1 when we talked about horizontal and vertical lines. When we just have a line that goes through the y-intercept, meaning, let's see, we have a y-intercept and the y-axis is the one that goes from up to down. So if we have a y-intercept, like if it goes through here, we've got -5, so it'll be somewhere down here. If this line goes just through here and has a slope of 0, remember slope of 0 lines are horizontal lines. So this is a horizontal line like this. How is that going to look? Is it going to be x equals a number or y equals a number? We've talked about this. What do you think? Y equals -5. Okay. Let's go down to 35. We have y equals 1x plus 7, or 1x is just x. You can write it as y equals x plus 7. Okay. 37, we have a slope of 0 and a y-intercept of 0. Well, we know that a 0 slope means that we have like up here, a horizontal line. Horizontal lines have a 0 slope. Y-intercept equals 0 doesn't mean that there's not a y-intercept. There is a y-intercept. It's just at where? At 0 on the graph. So if we, let's visualize this again. If we have a graph and it's a 0 slope, meaning it's a horizontal line, and this horizontal line goes through y equals 0. So where's y equals 0? Right here at the origin. So we have a horizontal line. Let me do it with a highlighter, otherwise you won't be able to see it. We have a horizontal line right on top of what axis? The x-axis. Okay, so how do we write an equation for this? Just y equals 0. Okay. All right. The evens over here on the left side, I'm going to leave for you. Write these all in slope-intercept form. Let's flip to the back. So on the front side, it was really, really nice because all the information we needed, the slope and the y-intercept, were just written for us. It was basically handed to us, and we just needed to write it in the correct form. This time, that information, it's actually still given to us. We just need to kind of find it. All right, so this time we have to look at a graph and figure out what the y-intercept and the slope is, and then we can plug it into the equation, just like we did on the front half, or the front side of this paper. Okay, so y-intercept, that's going to be the points on the y-axis where the graph crosses through perfectly, hopefully. So let's see, this line, it looks like it crosses through right exactly at -2. So I'm going to call my y-intercept -2. Okay, how about my slope? How can I figure out my slope? Well, the way you figure out slope from a graph is you, obviously, let's put a point where the y-intercept was, because we know that that perfectly goes through at -2. Now what we need to do is find another perfect point. Let me see if I can write this. Perfect point. Okay. So what does a perfect point mean? What I mean by a perfect point is, for example, if I follow this line, like right here, does this go through any exact point on this grid, like here, 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 or here? No, right here, it's between 0 and 1, so that would be like maybe 1.5. That's not a perfect point. I want to find a place on this line where it goes through, I guess you would call this kind of like a corner or a cross of the grid perfectly, like one of these. Do you see what I'm talking about? It's a perfect point. So let's see. I think that this right here is probably going to be the most perfect that we're going to get, because below it, it's not quite to 1 yet, if you can tell. So I'm going to call this my other perfect point. Okay. Now, how do I find the slope between these 2 points? How did we do it back in chapter 3? We literally just need to count. All right. We're going up, so it's going to be positive. 1, 2, 3, 4, 5, 6, 7. So we have a rise of 7 over run once. So our slope is going to be 7 over 1. So let's write this as an equation. Y equals mx plus b. Y equals m slope is 7x minus 2 for the b. All right, so that's our equation. Let's go down to 41. We need to find our y-intercept. So where does this graph go perfectly through the y-axis? Right here at -3. So our y-intercept is at -3. Now we need to find the slope. Once again, let's look for those perfect points. So let's follow the graph until it crosses perfectly. It looks like it crosses perfectly there, and there, and there, and there, and there. So really you can use any of these. I'm going to pick one that's kind of far away because I want to show you how to reduce the slope. So I don't know, let's pick the one right here. Okay. And let's count. Remember, when you're talking about slope, you need to count your slope going from left to right, okay? So it's kind of like you're a little person and you're walking, okay? So from left to right, rise over run. Rise. Are we going up or down to get over here? Looks like we're going to go down. So this is going to be a negative slope. Let's see. 1, 2, 3, 4. Down 4. Over. Let's see. What's our run? 1, 2, 3, 4. Negative 4 over 4. How can we reduce that fraction? It's going to be negative 1 over 1, or basically just negative 1. Okay? And we could have figured that out from any of the other perfect points that are closer. Like, for example, if I had looked at this perfect point, that would have been down 1 over 1. So each time that we have a perfect point, we're going down 1 over 1, down 1 over 1, down 1 over 1. So yes, our slope is negative 1. Let's write this as an equation. Y equals m, slope is negative 1, so just negative x minus 3 for the y-intercept. Okay? And one last one. Oh, let's see. We have a y-intercept at, looks like, negative 3 again. Okay. Let's find our slope, so we need to look for perfect point. Let's follow the graph until we get to another perfect point. This one right here looks like it could be perfect, but to me, it's still a little bit off, so I'm going to keep following my graph. Once again, right here kind of looks like it could be a perfect point, but still kind of looks a little off to me, so I'm going to keep following. I think right here at the end of my line, where it gets to the highest point on the graph, I think that that's going to be perfect. That looks kind of perfect to me. So I'm going to put a point there. All right, now let's count the rise over run once more. Remember to go from left to right. So let's start over here at this point. Rise over run. To rise, are we going to go up or down to get to this point? So let's count. 1, 2, 3, 4, 5, 6, 7, 8. So down 8. Over, let's see our run. 1, 2, 3. So we have negative 8 over 3. Equation, y equals m, which is our slope, so negative 8 thirds x, plus b, well this is negative 3, so we're going to have minus 3. And that's our equation for this line. All right, I want you to also finish these last 3. Once again, these happen to be the evens on the right side of your paper. Pay attention to your slope. It should match up to your line. So what I mean by that is here we had a positive slope. And is this a positive uphill line? It sure is. So those two things match. Down here we had a negative slope. Is this a negative downhill line? It sure is. So these two things match. We know we're good there. Here we had another negative slope. Is this a downhill negative line? It is. So those two things match, meaning that we did something right. So if those two things don't match, it means something's wrong and you need to check your math, or basically check your slope. All right? So don't forget to do these last 3 problems, also the summary questions on Schoology. Have a great night, and I'll see you in class.